What if I told you the best way to build a house wasn't to worry about building codes or floor plans, by le- but by leveraging physics and using a spreadsheet? It may sound boring, but I'm telling you, it is fascinating. And this shouldn't come as a surprise to any of you listening, but the way that we've evolved in many industries and the way that many industries are operating now is built on the assumption that the way we do things is simply how things are done, which in most markets leads to opportunities for an upstart to come in and knock out the competition and that existing status quo. In housing, though, that seems quite a bit harder to crack into, at least for now, because how we build our homes right now doesn't really consider all that much the spot on the earth they're going to inhabit, but is centered around four walls made of 2x4s and the minimum required level of insulation and roofing needed to hurry up and build this one to move on to the next one, straight on down the line. Something I think a lot about, though, with the way the world is turning, certain things like extreme heat or cold, or even having stable access to energy, are going to become things to contend with. In many cases, they already are. One of the solutions to this has already been formed, and it comes with a whole mess of other benefits. What I'm talking about is passive design, and it's a set of fundamentals for building structures, if it's residential homes, commercial office buildings, or even a warehouse. It's centered around looking at the structure from the raw physics of it, and it's one of the few things when building a house that will actually save money in the long run. Things like energy efficiency from needing less to cool or heat the structures, more resistant to things like fires, higher level of comfort, and so on and so on. Passive design completely upends the way that you traditionally think about building a house or even remodeling an existing one. And it can bring you a comfortable living space even when it's below zero outside, even if your heater is broke. It's all about how you take advantage of the fixed things, where the sun comes up over the horizon, how thick are my windows, how much heat am I trapping or expelling. Again, the physics of the structure. It sounds so simple, but in genius, there's always simplicity. With me for this episode to explain passive house design is Andrew Michler, an architect from Santa Fe and an expert in passive house methodologies. He's also the author of a book who's coming up on its 10-year anniversary, Hyperlocalization of Architecture. Really interesting chat. I really love this concept and this design methodology. I hope you do too. Thank you, Andrew, for coming on the episode. Thank you all for listening, wherever you are on our big, blue, beautiful planet. I hope you're doing well. Alrighty, real quick before the episode starts. If you like what you're hearing, however this is getting to your ears, please hit subscribe or follow on whichever platform you're listening to this through. And if you would, please give us a rating, as both of those help us get found. If you want to suggest a topic, someone for me to talk to, if you want to talk to me, got some feedback, good or ill, go ahead and visit the show at bandwidth.productions and drop us a note. Part of what I was doing with this from the start was a big, bold plan, and some of that's coming to fruition. If you want to be better informed about the world around you and a whole bunch of stuff going on that you probably should know about, subscribe to The Dial. We got a weekly digital newspaper that goes out that tries to find signal amongst all the noise. Because there's a whole lot going on that we should pay attention to, but tends to get drowned out by whichever thing is highest in the news that day. Spend 30 seconds one day a week, and I'm telling you, you're going to have a way better understanding of what's going on in the world. You can sign up for that at bandwidth.today, or check out the link in the description. Thanks, y'all. Enjoy. All right. Well, thank you again for taking the time. Would you just briefly introduce yourself?
Yeah, my name is Andrew Michler, and I'm practicing architecture in Santa Fe, New Mexico, and been doing projects throughout the United States for a number of years. And most of them have been based on using passive house methodologies. I also wrote a book about 10 years ago. It's the anniversary of it, called Hyperlocalization of Architecture. And at the same time, when I was writing the book and traveling, I was also building a passive house in Colorado, which was the first certified passive house in Colorado through Passive House International. So that was the last 10 years have been a bit of a whirlwind tour of building science and architecture and, trying to get projects completed on time and on budget.
Yeah, yeah, that's always a struggle in anything you're building,
Yeah.
software or homes. Yeah, I'm really excited to dive into all this. Thank you again. I don't know if I realized you live in Santa Fe, but I have it's been calling to me to go there, not just because of the Santa Fe Institute, but I hear amazing things about it.
Yeah, that's why we're here. It's we live right in downtown in a little 500 square foot casita, so we never use the car. It's the food is fantastic. There's always an art event or something else going on. So yeah, it's like living in a big city in a little city.
That's awesome. Yeah, I gotta bump up on my priorities to get out there. But before we dive in more, it's something I like to ask everyone when they first join, to kind of just break the ice, but also get to know the person a little bit more. Is what do you like to do that makes you happy?
What do I do? I love walking in cities. To be honest, it's one of my favorite things to do. That's partially, I learned that habit from when I was writing my book and traveling quite a bit back in the day. Um, I do like architecture, but it's not something that I do for fun necessarily. I do it for fun, but most of it's not fun. Most of it's just really just nerdy, detail work. But I really do enjoy making spaces, traveling to spaces. It's really fascinating to see how the world is created by humans over time and what comes next. So that's been fascinating. I used to enjoy writing, but I got that out of my system. I was a blogger for a long time.
That's funny. I have a couple of friends who used to blog religiously, and they have the exact same sentiment.
Yeah, is that right? Okay.
Yeah, they're like, I
Yeah,
don't want
yeah.
to do it anymore.
Yeah, no, it's kind of a fascinating. It definitely, 15 years ago, it was really picking up, and then that's where I really got into architecture. Was writing for a couple of blogs and seeing like the vast world of conceptual design to what was really built. It was just yeah, it's a fun way to learn a subject is to constantly research and write about it.
Oh, totally. That's a great way. Yeah, I like that you like to walk. We're kindred souls. I'm a big fan of doing that.
Yeah.
Anywhere I go, sometimes I travel just to do that. All right, so I want to ask you a couple of questions that kind of like set an aperture that we can kind of go in and out of. So starting with just some base terms, because I'm not sure everyone would know. What is a passive house? And is another way of understanding it is saying an efficient house?
Yeah, that's exactly what it is. And the first point of confusion, which has been something we constantly are trying to get people to see, is that passive house is actually a German word, passive house, HAUS, which actually means building. So these are buildings, any type of building you can construct is part of that term. And the passive part was kind of I wouldn't say tongue in cheek, but it was an appreciation for the low technology, high performance thinking around what we can do with buildings. So rather than using technology to solve the problems of comfort or energy use, it was primarily using the physics of the building envelope to solve those issues, to create shelter that protects us, and through all kinds of weather events. And the passive part is that it doesn't take very much energy, if any energy at times at all, to maintain these comfortable spaces.
Yeah, that's really interesting. It makes you think of one time somebody told me this. They go, "Do you know what the difference between American car design and European car design is?" And I go, "What?" They go, "Americans put a bigger engine in the car, and Europeans make it more aerodynamic and efficient."
Yeah,
It's kind of the technology here. We can brute make a more efficient AC unit, or we can make it so that you need a tiny AC unit for the house, which is what it sounds like you're saying here with passive design.
yeah, and driving an electric car now for a few years, it's the same idea. If I go across to California and back quite a bit, so like efficiency is still the name of the game in everything at the end of the day. And we're just going to have to learn that culturally, That's just going to have to be normalized. And watching, who knows where this leads, but watching the oil crisis, that's a human caused intervention, which would not nearly been such a big deal if we understood efficiency more cleanly and more succinctly and adapted to it in a real way. This wouldn't be a crisis. This would be a spat.
Yeah, if we can only look above the horizon past the quarter, maybe we would be able to see that coming more.
Yeah,
Uh,
exactly.
so I heard you say this right now, but then I also saw in some of your writing and also the YouTube that you had with how do you is it Kirsten? How do you pronounce her name? I'm sorry.
Yeah, I believe it's Kirsten.
Kirsten. Okay, Dickerson, right? Is that her last
Yeah,
name?
yeah.
Yeah, or Dirksen. I'll link it below. So I'm sorry. I'm sorry, Kirsten, about butchering your name. Love your channel. Okay, but I heard you say there as well
And
as
Fast Companies, right?
what was that?
The name of her channel.
Oh, what is it?
Fast Fair Companies. Sorry,
Fair
Fast
companies. Yeah,
Companies.
I
Fair Companies.
fair companies. Anyways, I heard you say in that YouTube video that you were in with her, and then also some of your writing, and you even just mentioned it right now, is that passive house is really something that was developed by physics instead of building or building an architecture methodology starting from that. It was more starting from physics. Can you explain that, and can you explain a little bit about how that practically evolves into the structures that you build? Because I also like that you made the distinction that we think of it as passive house, but really it's any structure that could be passive.
Yeah, and the other side of the passive part is that it's also not necessarily passive solar. So, um, and the whole green building movement. I lived off grid since 1995, and was really interested in the whole kind of concept of what that means. This alternative living thing means in Colorado, especially. So, started with passive solar, and there's a big movement in the United States around that concept for a long time. And then there's two versions of that. There's solar active solar, meaning providing solar panels for either thermally for heating or solar electric, and then using lots of windows and thermal mass, things like that. So that became part of the vernacular of green building in the Southwest and many other places. And then when it became commercialized through the United States Green Building Council, and to the LEED system, which a lot of people have heard because you see these LEED plaques on all sorts of buildings. That was kind of a way of dealing with green building from an industry perspective. And it turns out that it was mostly just kind of taking code and then gluing things onto it, if that makes sense. So if code says you do this, then you just add 20% to that.
Yeah. So
Or
so if like a hot water pipe needs to go through, you wrap it up in insulation, or if ventilation it goes through, you just wrap it around some more to try to help thermo insulate it a little bit more. Is that essentially what you're saying?
yeah, it's fundamentally that was fundamentally the mindset. That wasn't a physics mindset. That was an industry plus kind of mindset. And then, but again, it was all people who were practitioners of buildings in some respect, one way or another, which makes sense. But in a couple of guys, Bo Adamson and Wolfgang Feist, who were basically professors um, in physics, took on the idea of, well, what if we looked at buildings just from the purely physics point of view? And how would we create buildings, especially during oil crises and afterwards? How would we develop buildings that were not dependent on fossil fuels or burning wood, for instance, or other things? So they did a lot of research over the years, and from drawing from all sorts of different sources, um, they developed a system called Passive House, which was really a very sophisticated piece of software or calculations, Excel based calculations that you could actually simulate the building, the physics of the building in pretty deep detail. And then another uh, Amory Lovins, the guy who started the Rocky Mountain Institute in Colorado, who built a super efficient house up there, recommended to them that they take that physics model that they developed in university and turn it into an actual system that you could use as a certification process. So that's where the idea of the Passive House Institute and Passive House, as we know it, started from. So they could be universally applied and consistently applied.
That's interesting. Um, so taking it another step lower, when we think of it and that's those calculations that they did and building a more physics oriented structure as opposed to codes or the way I like to think of it is like this is just how we do it. How does that actually play out? How would that play out compared to like a stick structure that most American houses are, right? And stick being like 2x4s that are all strapped
Yeah,
together with plywood, and then they throw on a single sheet of insulation and kind of call it a day.
yeah,
What are some of the differences to it? Like I know one of them is kind of sealing off the structure from not allowing air to come in and out of it. What are the layers in which it kind of goes into the thought process of if you look at it from base reality up, as opposed to we have a toolbox and some 2x4s. How do we throw together a house that has some dwellings that keeps the rain out?
right. And so that approach that we would consider code or code plus, or even kind of net zero type of buildings, net zero energy buildings, would be called a prescriptive approach, meaning that here's you need an R something wall, yeah, which is the or a U value if you're in Europe, um, and you need to put this efficiency appliance in it and this kind of lighting, this type of plumbing. So those are prescribed, while a passive house would be more of a performance based. But that performance is based on a target. And that target is extremely aggressive in terms of the actual energy you can use to heat and cool the house and run appliances in the house. So first they created a performance model, and then they created a kind of a target that was challenging to achieve, but achievable at the same time. So that was kind of, people say it's arbitrary, but there's a number of reasons why they created that target. But at the end of the day, that target meant that we were building buildings that had a lot more insulation. They were a lot more airtight. They were able to heat and cool using solar gains or solar protection, and that they got to the point where they accounted for like how much heat was generated in the building by the occupants and their pets and the showers and all that. That's part of the calculation. How much is lost just through every little point of contact the building has with the exterior is accounted for. Um, and then the construction of it. So when you do a certification, you're actually have a third party verification process that's involved with that, which is really critical. You can't just say, hey, I did this and pat yourself on the back and go to the next building. So it has to be quantifiable as well. And there also needs to be, they also have a product certification. So, like when I buy a product from a window people or for my ventilation system, that is guaranteed to perform as they say using proper, testing methodologies. So every step along the way has a kind of a QA process to it.
It's interesting. It seems like it's well, it doesn't seem like it. It definitely is a lot more meticulous into how it's being put together. I mean, calculating how much my heat my dog is emitting to be able to go into the house is fascinating. So what you're saying is, every from the way that the windows are put together, like I saw in yours, it's triple pane windows, or where the windows are facing. Is it north facing, south facing? Overhangs of the building for the windows, and how that affects the sun hitting and then ultimately heating the house or cooling the house.
Mm-hmm.
um, all of that goes into it, and everything that could possibly affect the transference of air or energy, because heat is energy, right, from the house outside, or vice versa, is put
Yeah.
into this in such a way.
Yeah, exactly. In your earlier acts, kind of what is a passive house? A lot of people thinks they're boxy buildings, and that comes from the physics principle of the form factor is what we call it. So the more simplified the building is compared to the living area, the exterior shell of the building, uh, then the less actual energy is lost or gained through the building envelope, if that makes sense. So if you think of it as like a glove in the wintertime, if you know, compared to wearing like just a glove with your fingers, once it gets really cold, you want a mitten that covers all your fingers and bundles it so it reduces the amount of surface area to the exterior. That's the same principle of passive house. But you don't necessarily have to do that. The model doesn't prescribe that. You're architecturally free to work with that as a principle, but you can articulate the buildings in really interesting ways, just as long as you're careful and thoughtful about that. But a lot of people also thought it was boxy because they saw a lot of German buildings in the early ones, especially in '90s and in the late '80s, that were boxy. That's German code. Turns out that it was just a happy coincidence, but it was as much based on German building codes and Austrian building codes as it was the thermal dynamics of the building.
That's funny. It sounds like it's more of this is the guideline of what you're shooting for, and if you want to make it funky and different as far as what the building aesthetics are, design, or rafters or any of those things, you could do that. But it's trade-offs, right? It may be more challenging in one place or the other, or be more expensive in one way or the other. But it's all just levers to pull for. And kind of
Yeah.
the the last question on this section, before I go to kind of leading us a little further, is it sounds like the passive house isn't necessarily do this, don't do that. It's a set of fundamentals and guidelines to be able to shoot for of what the end result is. Is that a fair way of putting it?
Yeah, I think that's exactly it, and I'm glad that point came across that it's quite different mentality, and we use it as a design tool to and methodologies to kind of at the end of the day you can't see how a building performs, but you can measure it. So so the idea of that of creating buildings that we understand how they work in the real world is quite empowering in that sense, and that's that I had a really good word for it, but it's basically just it's just a practice. It's just a methodology that that when people really incorporate it, they really take hold of it and have a hard time looking at regular buildings, and you almost can't go back and design a code built building again. It's nearly impossible. Um,
Yeah, I mean, I can tell you this much. I've never built a building before, but for the several years I've been getting into passive house design, I look at every building and I even look at my own house and I get frustrated. So
yeah, yeah, that's kind of that's the hard thing. Is sort of like being a mechanic working on high performance cars and driving your souped up, VW Golf you bought in
yeah, I,
diesel that you bought in the '80s. Yeah. So
yeah. I build software, but I also build other things, for what I do, I guess, for my life. And my wife always gets annoyed with me because if I take something, buy something and start putting it together and I realize it's poorly designed, I put it back away and return it because I'm not dealing with this. But it's different with homes or buildings because it's a lot harder to do that.
well, I
Um,
was lucky that I got to build my project for myself, the first project. So I really got to challenge myself on the design, articulating the materials, specifying the materials that were a little bit less environmentally unsound, and also experiencing the building for the past 10 years in Colorado, 7,500 feet. And that's been quite the pleasure to like have a building I don't have to worry about. I don't have to worry about the heating. I don't have the heating system on in the wintertime when I'm not there. It just doesn't freeze,
yeah.
no matter
Okay. So
how cold it gets out there.
I wanted to actually mention this, and this is a great point to do it. So I saw from a post that you had made when you had traveled to Japan that you didn't have the heat on and it got below zero in Colorado, but your home essentially never got below the 50s, I think it was.
Yeah, I believe it was -9. Yeah, it was -9 a couple of nights. And I was looking just when I was in Japan, I was just checking the thermometer at home, and I think it was in the mid 60s, and then dropped down to 60 degrees. And, the second the sun shines, the house was stepping up in temperature again without a heating system. So that was really cool. And it turned out to be really good because there's times when we had that big freeze, the one that hit Texas. We all remember that when Texas froze. We had about a week where it was -10 to 0 degrees. No, actually, it's probably it was even colder than that at times. Basically, the water pipes froze to the house. So I used my hot water tank to heat as the heating system for the house, and that didn't work without water. So I had guests at the time, and I was so freaked out. And they put on like their coats. I was like, "Are you guys okay?" And they're like, "Yeah, we're fine. We have no complaints." And they were writing an album at the time, so it was really interesting, for better or for worse, to see when the heating system actually did fail, how the house fared in like the most difficult winter conditions possible.
Yeah, for sure. Okay, so can you talk more about how that's possible? So it was both how the heck is your hot water heater heating the house? I think
Yeah.
Dwell magazine, yeah, Dwell magazine. I like perusing that occasionally, and I saw somebody lady who had built a passive house, and they had an expose on her, and she talked about how her to heat her home, it's so small, it's as if she just uses a hair dryer. But in your particular case, how do you use the hot water heater for it? And also, what are some other the things that you've done in your house that are both using the specific geography of where it's at, as well as some more of the physics, like I think I wrote down the tubes that you have in there, the earth tubes, yeah, earth tube. What is that, and what are some other things that you've done in that house to be able to make it we get deep freezes where I live off Lake Michigan. This past winter, I think we had a couple weeks where it was essentially zero or below zero for that whole time period, and I don't know if there was a moment my heater turned off.
Hmm. Right, right. Um, so the hair dryer is really more of an analogy. A hair dryer is about 1,500 watts. So the analogy is that that's your energy budget to heat your home with. Um, so, so it's not that it's just something people can kind of visualize.
Yeah, yeah, it wasn't
Heat
literal. Yeah,
source.
yeah, yeah, not literal.
Yeah, you could. Somebody did actually test passive house and heat it with a hair dryer one time when it was really cold in California, and it worked. So, but the same thing is like, since I don't need a lot of heat to heat the house, I could just hook it up to just a dumb hot water heater and just run a pump to a couple of coils, and that's sufficient to heat the house up. Is that general principle, and it works because I got kind of lucky. So I bought this cabin, solar powered cabin, in the mid '90s. Um, that's why I learned that like co-construction was rubbish, because I was constantly having to have a fire all the time. And even when I did the quote unquote passive solar with thermal mass, in some ways it made it a little bit worse, because once the thermal mass got cold, it would never heat up again,
Hmm.
very, very well. So even if like, oh yeah, well, sure, the ground is warm. The ground is warm for the ground, but not for a human being. So if it's 60 degrees, your floor, you're going to feel that all the time. It's going to be constantly draining heat off of your body. So in a passive house, you're creating thermally neutral surfaces primarily. So you don't constantly, like if you in Michigan, I'm sure if you're next to your window when it's 9 degrees out, you can feel that heat just being sucked out of your body, right?
Oh, totally.
So
Even my double pane windows. Yeah.
yeah, Yeah, absolutely. So we're trying to avoid that. So that's the comfort part. And then marry that with the low energy usage part. Those are the two main primary conditions for outcomes we're looking for.
So what are the earth tubes that you have in that Colorado house, and how do they
Yeah.
work? And then how does that pair with your hot water heater to be able to make the home warm?
So the earth tubes, that's something I didn't really mention. And this is one of the very first questions. If you read comments for any passive house anything, videos or literature, most people will say, well, I like to breathe fresh air. I don't want to live in a concealed box. The first thing is the passive houses are made to be naturally ventilated. So you can open windows. Think of like a parka. You can just unzip your parka. You don't always have to have it zipped up all the time. And the other part is that there's a ventilation system that's running 24/7. And so that's the one necessary prescriptive piece of mechanics is a ventilation, fresh air ventilation system. So the earth tubes are feeding the ventilation system, which has a heat exchanger in it. And it's basically taking the stale air out of like the kitchen and bathroom and putting fresh air into the living rooms and the bedrooms. So you're getting a constant recirculation of fresh air. And the earth tubes are designed because this house was off grid. This is I'll call it kind of hippie technology. It's been around for a long time, but the idea was when it gets really cold, these heat exchangers can freeze up, which is pretty scary stuff. So they put these heating coils in them. They don't use a lot of electricity, but when you're off grid, that's about the worst time to have an energy demand is when it's the middle of the night, especially during snowstorm. So the earth tubes temper the air so that when it comes into the pipe, it might be at coldest about 50 degrees or 45 degrees at the very coldest. I don't think I've seen it below 50 degrees.
And,
Um,
and these tubes are literal tubes that are dug into the earth.
yeah, yeah, they're put behind the foundation and they're just bringing in fresh air from the outside, but they're designed so it doesn't have that -9 degree air coming into the heat exchanger.
So the -9 degree air, there's a hole somewhere that's sucking in the -9 degree air,
Yep,
and then it's funneling it through a series of tubes underground. Which by
exactly.
doing that, you're exchanging the temperature to that of the ground temperature, and then funneling that into the house.
Yeah, exactly. And you can do it for a little bit of cooling in the summer as well. You can help cool the house. Not a lot, but a little bit. I don't have air conditioning in the house. One thing I did learn is that the house can definitely overheat now. And I'm going to go ahead and blame climate change for that a little bit. Our falls in Colorado have gotten really, really hot. And here in Santa Fe, the forecast for next week is 86-degree highs. So when you build a passive solar house, this time of year, we call it the shoulder seasons or swing seasons, spring and fall, the sun is still low, right? So we're still getting a lot of solar heat gain before our passive eaves kick in and protect the house from the solar gains in the summer. So if they don't work, especially in the fall, the houses start getting much warmer than they were anticipated for. So I'll need to. I do have what we call a swamp cooler, evaporative cooler, which works pretty good most of the time. But I also need to put in active shading in front of the windows, which is vernacularism in Europe. Almost every building in Central Europe and Southern Europe has window coverings. This is something not in the US yet. But we
Yeah,
are putting in them into our passive houses in the US now.
yeah, window shading, or this is also something else that you mentioned too, of like tree cover and things like that. Like, it's
Yeah,
it's no surprise that if you go into the U.S. and you see any century old or older farmhouse, that they're usually covered by surrounded by a lot of oaks. You'll be driving down the road, country road, and it'll be cornfields, and you see a squared off set of trees, and then you'll see a farmhouse in the middle of it. It's no surprise. They were
yeah.
intentional
They're
in
creating a
doing that.
microclimate. Yeah,
Exactly.
we forgot how buildings worked and how to create climates because of air conditioning. Essentially, air conditioning flattened the architecture topography of the United States, famously so. and now it's doing it for the world. So learning to build adaptable buildings, climate specific buildings, and adaptive, built environments is like a central principle in the future, but it still hasn't really gained traction in the design community because there's all these other kind of conflicting methodologies and use cases that can be solved by air conditioning.
I was about to say it's the technology paradox, right? Like we have this, so why would we not think of just using this? We have this great hammer over here. Why not we just use this hammer instead of thinking about screwing it together?
Yeah,
Um, what is the cost breakdown for a passive house to a traditional house? And to kind of load the question just a little bit,
yeah.
how long would it take for it to be essentially net neutral between the two?
That's a good question, and when you talk about cost, because we have to deal with it all the time, it's the answer is always it depends. And the first thing is that most passive houses are custom homes, so you can't compare it to just a large scale builder who's building code minimum homes in the middle of a wheat field, right? So it's hard to get that apples and apples comparison. Um, we do have some actual really good comparisons now. I'd say in mild climates like California, there might be like a 2% or 3% cost increase between passive house and regular construction because it's not that far off of regular construction. And I know that because I'm doing fire rebuilding in um, Los Angeles now for passive houses. And we also did them in Colorado. We did a number of fire replacement houses from the fires that hit Boulder a few years ago. And we did that in a very typical neighborhood. And my builder says there's about a 10% increase in costs compared to conventional building for them, which I thought was really good because in Colorado, I can tell you what energy, I don't know what Colorado energy prices are because I live off grid there. I can tell you what California is. And we're looking at 50 cents a kilowatt hour, right? So you're going to easily get a $400 bill a month if you're heating and cooling a house. So if you can reduce that down to $20, $30 a month, the payback is pretty quick in a milder climate when you can look at the cost overhead of being 3%. So maybe for $1 million house, that's going to be $30,000. So say $500 a month, $300 a month. I'm not that great with math, ironically.
Well,
So
I would actually probably say that if you're building a $3 million house or $2 million house, it's probably going to be a lot more than that to heat it or cool it, right? I mean, like when I was in California not that long ago, I guess 5 years ago at this point, but when I was out there, my little 500 square foot apartment would sometimes be $120, a month
uh, yeah,
bill.
yeah,
So
yeah. And once you start talking about 2, 3, 4, 5%, honestly, your choice in anything design based is going to be within that range of influence on the building.
literally, your kitchen countertops
Your
could.
kitchen, your siding, your roof. I mean, the engineering. I have to say, once we start putting moment frames in our buildings, so we can have a larger set of windows somewhere, or I want this specific type of staircase. That's it depends. There's a point when you don't actually see it in the scope of overall costs. I will say that in terms of decisions made in the building, it's one of the very few decisions that does actively save money over time. Nothing else is going to save any money. On top of that, you get the comfort, you get the quality assurance scope, which is something that's the dirty secret. Most of the buildings that are inspected miss a lot. There's a lot of hot garbage being thrown together at a lot of money. spent for things that are not very good. It's the same people who are building your McMansion or building your stick track house. It's the same people. So having a system where people are overlooking the quality of the installation and testing that is like fundamental. Just paying for that alone makes it well worth it. And if you get certified, who knows in the future, we may actually have a real estate kind of come to Jesus moment where they realize that yes, high quality, high performance homes are really important, and we place value on that. So
That's actually the other thing that I was thinking about as you're talking is, there's the savings, but there's also probably the value, right? Like a passive home is going to be able to have that resale value to a degree that I would imagine be above a traditional home. And
yeah,
something that made passive homes more on the radar, other than nerds such as myself, is there was a few houses in Malibu that didn't get burned down in the fires that were there recently because they were passive homes, and also they didn't have as much, if any, of the smoke damage on the interior of these, because there was a bunch of homes, as I'm sure you're working there, for
yeah,
those who don't, your house may have been saved from the actual fire, but it has to be demolished anyways because the smoke made it uninhabitable.
yeah, exactly. And that, in fact, in Altadena, one of my projects, the it's surrounded by houses that didn't burn, that get singed. But I slept on the lot one night just to get a feel for the space, and the entire neighborhood was uninhabited. The buildings were you couldn't live in these homes. So the retrofit of them, either some of them have to be scrapped, others have to be completely torn down, insulation removed, and rebuilt essentially from the inside out. So that's a big part of it. And that Los Angeles thing that did make a huge national news. There was one house that was on Reddit
That's
that
probably where I
somebody,
saw it. Yeah.
yeah, I saw it on Reddit. So my friend called me one morning and said, "Oh my God, Andrew, look at this!" And it was linked to one of my presentations, I believe. And so my friend followed up, and it was a guy in Ireland. So here's an inside scoop. Apparently, he followed up with the guy at the poster who posted that Reddit and said, "Hey," and so basically, it was a house that was sitting surrounded by ashes. It said, "This passive house survived the fire." If you look at the house, it looks like the German vernacular type of house that I was talking about. So then he linked to a presentation I gave on fire rebuilding based on the Colorado fires. And the link was the passive house has much higher survivability because of this physics. And then you add good materials with the good physics of passive house, you have a very high fire survivability kind of condition. Um, the house was not a passive house, as it turns out. It was just a regular house that somebody said they used passive house principles on. So it was a better built house, but it had steel cladding, it had good windows, it was airtight. CBS News was calling us. It went super viral, but we'll take it as a win.
Yeah.
In the sense that hey, um, the survivability really is based on like some really basic understandings of how buildings work and best practices. So, the fact that the architect was not shy saying, yeah, I did, I was influenced by Passive House, even though it wasn't an actual certified Passive House. That's great. That means the industry is moving and changing, and it's really starting to filter out deeply into the design and build community.
That's hilarious. That's such a truism for our time. It's wasn't actually real. It was real, I guess. It didn't burn down, but it wasn't actually a passive house. How
Oh, I
hilarious!
got stories as a blogger how misinformation spreads. When it goes viral, man, you're lucky if like any of it's actually sourced correctly from the
Yeah.
original
What is it, like
material.
the a lie goes around the world before the truth can get out the door? Right? Isn't that something like that?
Yes, it's true.
Um,
Even with fact checkers.
yeah. Does that even exist? Back to AI though. But anyways, what what makes it more survivable? Is it just, and is it also more than just fires? So like something, living in the Midwest that I think about more and more frequently. Especially, we just had some storms recently, and
Mhm.
the storm that passed through. Since I'm so close to the lake, speaking of microclimates, I think about this all the time of how grateful I am because, 20 miles south of me, sometimes even 5 minutes drive in any direction from me, the storms that come through will be way worse for them. But because of the temperature difference between the lake, it'll be different by me. But something I saw recently, Illinois had 6-inch hail, like that broke records,
Oh,
multiple inches over what was the previous record, and the winds that come through now are much crazier than they used to be, and just generally storms are. In North America has the most energetic storms in the world, and it's getting worse. So storms are getting worse. Fire risks are higher. What makes a passive house better, and I guess another pithier way of putting this is climate change versus a passive house, which wins?
uh, that's kind of the question. How are we going to survive the next century? And these buildings are going
How
to
do we
be
thrive
around.
is the way I like to think of it.
Yeah, yeah. I mean, we can start with survival, but thriving sounds pretty fucking awesome,
Yeah.
right? Uh, so, how do we actually thrive in really difficult conditions? And these are conditions that you don't design for. You don't design for. You can try to design for tornadoes, but the physics really means you're building bunkers. And that's not thriving. In a fire condition, and my house that I grew up in burned in 1991, the Oakland Hills fires. That's when I first became used to it. We've been evacuated half a dozen times or more from Colorado, from our house in Colorado. So think about fire a lot, and built in a lot of fire areas that have already been hit by fires. So these conditions are really extreme. I don't know what you do with 6-inch hail. I guess um, you just hope that you're in the right place at the right time in those kind of conditions. Um, but when it comes to like a tornado, hurricane, fire event, um, that's where the form factor starts really coming in to its own. The less actual surface area, the less actual the less actual places that wind can get in and disturb the structure. You have less surface area for the winds to work with. The less articulations um, means that there's less places for embers to get driven into. So if you have a complicated roof and you have complicated gutters, or you have maybe some debris or anything, you can easily get firebrands into those spaces. Once they get into those spaces and take root in behind your siding, it's game over. Um, Often we look at like how we need to have our buildings uh, transport vapor from the inside to the outside in cold climates, but that also means we have to have air go through our assemblies. That air can also introduce embers at times, so being able to protect that means that we're putting materials in that are airtight, so we don't have the smoke and the intrusion of fire embers. And then we also have for passive house, this is not passive house specific, but where we're focusing on a lot, and we're actually doing a presentation with the University of Texas in Austin coming up, is the materiality in fire. And we have some wall sections we're displaying on campus that shows how passive house materiality assemblies and fire work really well together, can work really well together. So that smoke and intrusion issue is taken care of by the airtightness. The the If we have a simplified form factor, so we don't have a lot of eaves, a lot of dormers, a lot of complexities coming out of the buildings, which maybe a vernacular that's makes us say it's home, but a lot of it's expensive and useless, to be honest, and does not improve the quality of living for the occupants. I'm more of a contemporary architect, so it doesn't really mean much for my personal architecture expression, which kind of helps. And at the end of the day, good windows that are protected, the windows will often fail in a fire. Interesting. They're a very, very vulnerable place. So the triple pane means that there's that fire heat front can stress the glass can crack. If one heat embers get around where the framing is, which is a really complicated little spot. The frames can catch on fire, fail, and then the glass can fall out, and then again it's game over. So all those little details, those devils of details, the passive house is not too far from like extreme events like fire, or if we have a hurricane. Outside of like the engineering's gotten really good for buildings, so we strap the bejeebus out of these things, but Passive House had a layer protection just on the form factor side of that.
Yeah, that's great. And what I'm really hearing here is that uh, there's no such thing as zero risk. Even when the risks increase, it makes it more difficult.
I
But
mean, it's like the Tesla truck. You know, it's sort of like you make a cyber truck that's supposed to float, cost $45,000, and drive you somewhere. You know, we can't. That's not a thing. Like we build boats because they float well. You know, we build trains because they drive in the right direction. You know, we build trucks. You know, I building for years. I have a truck with a good truck bed. They have good access to, so I can put stuff in it. All these things have specific reasons. So when you try to put everything and be everything, you often are not. But there are certain conditions when you're already building something well. Well, yeah, like the efficiency of the Tesla truck's fantastic at the same time, or any electric vehicle. You know, it's using 1/10 the actual energy that a gas car would use, just from the raw physics point of view. So my bill to charge my car at home to fill it from 0 to 90 is about $4, right? And I don't even know what gas prices are. I haven't filled up in years at this point. So there's you find your strengths and you build to them.
yeah, yeah, and it sounds like the one of the many things that I really like about passive design here is it sounds like you solve for the base physics of it, and you get a lot of other things that you essentially get for free. And one of them being, a better tolerance to extreme events or whatnot. No, there's something that I think about. I think about this a lot with my house. So, I'm a big fan of Frank Lloyd Wright in particular, which he also had a Japanese influence, which I'd love to get into
Mhm.
in a moment because I know you're a fan of that as well. And I live in a house, one of those split level houses. It's kind of the mass design of the Frank Lloyd Wright influence in American construction, and there's a lot of things that actually end up overlapping between what he did, such as the placement of windows, and ultimately knocked on into my house. Like my big windows are to one side of the house, the south side of the house, which is nice when it's summertime and better when it's wintertime. There's easements in there that make things easier for the sun overhang. Even that it is a split level is its own level of efficiencies. But what I'm really wondering is, can you take a house, some may be further along, like mine, or one that's even less along, and can you, for lack of a better word, pacify it to make it more passive house? Can you do that? And I guess there's
And
ultimately, I would imagine there's a diminishing return. Like you can throw in triple pane windows to my house, but the stick structure of it is probably going to be that RR insulation value is going to probably be relatively low regardless of even just doing that. But I'm wondering, is there any way that you can take an existing structure and pacify it, or is it something that is almost better suited, kind of like taking a Mustang and trying to make it better on gas? You might as well just buy a Prius.
yeah, and I like the idea of your terminology of pacifying it because it's an active thing. Um, the answer is yes, and there is a certification called Enerfit, which is a retrofit, energy retrofit, essentially, and its own certification process. I currently own a house in Oakland, California, that I'm doing a passive house Enerfit retrofit for. And retrofits are never easy, no matter what. So it depends on like the scale of need for the building. For doing it just on its own, just if you have a really good house and it seems to function well, maybe it needs some new windows. That's about it. It's not going to have an energy payoff, most probably. Um, but for instance, this house I have in California, I had to strip down quite a bit of the elements downstairs, and I'm going to, because it's in a fire area and the paint's peeling, I'm going to have to re-site it anyhow. So I can. So a passive house is not that different from a regular house. It's just more of it in some ways. So I can take a 2x4 building, which would be my structure of the building. Well, that are my passive houses we design are a 2x6s, 2x4s, and then we just put an exterior insulation system on that, and then we took and between the exterior insulation and the existing structural wall, put an airtight barrier on it, and you have yourself a passive house. So it's not it's not extreme in that sense technically. There's some really weird, it depends kind of conditions where, like if you have a basement and you have to insulate, that can be that means you either have to insulate underneath, which means taking the concrete out, or insulating above, which means building insulation up on the floor. So that can be one condition. Um, there's conditions where the roof is complicated, how to create that airtightness or provide more insulation. So do you have to build up your roof? Are there spots where you have like a big chunk of steel coming in and out of the house, or in my case, a couple fireplaces, and how much energy do I lose there? So those are all calculated and taken accounted for um, in the model. And I would suggest, like, even if you don't go for a certification, just just planning for the future, putting in the best windows you can get, putting in the best insulation you can get, really looking at how to keep air from going through the walls really helps. And if you can actually do a QA process that's much more involved for like a deep retrofit, then it definitely seems to pay off in the long run.
That's great. Yeah. So what I'm hearing here, I'm pained with regret that when I put new siding and a roof on my house, I should have spent or even known to do this and thrown another layer of insulation on the outside. And
Yeah, no, it's and this is what really bothers me is that the building code, the construction industry is so bifurcated that the peoples who put on the siding could make money if they said, hey, for so much money, we'll add insulation too. Well, it doesn't even occur to them. That's just not their thing. So it's really up to you to, hey, can you do this? Can you do this? There's not really a, usually for code, it depends on where you are, but code often doesn't really require airtightness, especially in retrofits. So there's all these kind of lost opportunities just because we don't know. And the people who you call to ask, they will often talk you out of it because it's a pain in the ass. And you don't make money when you have to learn something new in the construction industry. You make money when you do the same thing more quickly. So,
yeah, it's
yeah,
it's a reframing though, right? Because there might
it
be
is. It is. Yeah.
might be more opportunity if you did learn that new thing versus just trying to build more track homes.
I've made peace with myself on that part of the building industry, and I'm just going to go ahead and do the best I can on my own personal projects and hope for the best for everybody out
Well,
there because it is a huge cultural problem to solve.
yeah, isn't that the issues of our time? The thing though that I'm thinking about now that I'm kind of bringing it back to that you said earlier is that most passive homes are custom homes, but to me it strikes me as that there's a huge opportunity if we were to have some type of standard home. Like okay, so for example, the house I live in, it's a split level. I've seen a bunch of those. You can see a bunch of similar homes to mine. Anywhere else, but what you could do if you had something similar to that of saying, oh, hey, here's this design, here's the layout, this is what the range of installation looks like, the range of possibilities looks like. So there is more of a off the shelf that you could start with. That seems like a huge opportunity to be able to have
Yeah,
that.
there's definitely opportunities there. For instance, our fire rebuild, we created a project called the Restore House, and it was just a basic design. All the lots were the same. 190 houses were in this one subdivision. So we designed a house that could fit any of the lots in a subdivision. We built three of them. Um, we weren't we weren't we're still kind of all came from the custom home industry, so the clients did get away with a lot of customization that caused excessive re-engineering in my mind at some points, but the concept still remained. We still had the same systems from all three of these projects, so overall that was quite successful. So there are some developers who are making custom passive house neighborhoods. Um, where we really see it taking off is in the panelization in factory built scope of passive houses. In fact, how many do I have? A number, six projects that were built in factories, the panel as panels and erected on site. And so every lot's different, unless you're a big developer and you really know what the hell you're doing, it's going to be a challenge to like get that level of quality done on site by conventional construction. So by building it, the panels in the factory that can be custom for either the same type of house over and over again or super customized for individual kind of high level architecture. That seems to be the sweet spot right now. It does not necessarily, it doesn't save money, but it saves a lot of headache and it's scalable. So that's kind of where we're seeing the industry move to. And the biggest place for passive house really is in the multifamily sector. That's really its strongest space because that conversation about the form factor before, your insulation systems are pretty close to standard construction. And so then it's just getting the detailing right and getting the right mechanical systems in. So the cost overhead is a lot less. The performance is really quite high in there. And then I'm speculating, but I suspect that because the energy costs are so low, if you're an owner of the building, your savings and economy on energy can be tied into a profit margin as well.
That makes a lot of sense. Yeah, and I would also imagine that all the things you're saying as far as the durability and quality and um, risk tolerance, for lack of a better phrase that I'm kind of reaching for, is if you have multiple dwellings within one structure, it makes it a lot easier, right?
Yeah, yeah, it
That's
makes it a
interesting.
lot easier. Yeah,
Um,
and then same with the panels. Like we're working with, I have four different types of panels. One's made from straw, in fact. The other two are made with cellulose, and one's made with mass timber. So there's quite a bit of invention there in ways to apply that part of the building process as well. So Passive House tends to be people who are kind of like leaders in innovation and try something new anyhow. So it's kind of a natural place for people to innovate new processes and products that go mainstream.
yeah, that makes a lot of sense. I'm uh, I'm really interested in timber structures as well. The cross section between timber and passive homes is something I'm also very curious about. But I want to ask about your trip to Japan, and you had mentioned that you were going there for looking at contemporary architecture, and I'm curious to see what inspired you while you were there, and kind of the delta between contemporary Japanese design versus contemporary American design.
Yeah, there's it's a really interesting delta and something I've been thinking about for. I did write about Japan on how they built like micro tiny housing in Japan, but it was so effortless and inventive and interesting that I was there originally about 12 years ago. I've been there a couple times since, and this last trip was by a group called Arca Marathon, run by a couple of guys from Melbourne, Kevin Hui and Andrew Maynard. And Andrew Maynard is half of Austin Maynard Architects, Melbourne, somebody I've been following for a long time. So bit bit of a folk hero to me as an architect. So it was fun to like run around the island of Japan for a couple of weeks with him. And then Kevin Hui runs the Arca Marathon. And they do architecture tours all around the world. And you walk and you walk. We were doing about 10 to 14 miles a day of just walking. And they do that everywhere. So that's a pretty rare. There's very few people who look at buildings that way, like I would normally look at a building, as I said, for fun or yeah, at architecture. So we went from pretty much the 50s or 60s of Japan contemporary architecture up to current day and scale from everywhere. Mostly it's called the classic tour, so it's mostly from Kobe to Tokyo, and then Osaka and Kyoto. And the Japanese are brave. Like they really, really place a lot of emphasis on the quality of the design at scale, in small scales or large scales. There's like this very interesting creative use of materials. There's a strong tradition of building and craftsmanship, of course, from the temples. They tear a temple down every 30 years and rebuild it just to keep people trained on how to build with wood. So that clearly has been well established within the trades building community and the architecture community. And I went there uh, for details. So I was just shooting a bunch of film of details so that I can learn. Like my weakness is understanding how to incorporate detailing correctly and translate that level of craftsmanship into the actual like construction of the buildings into my own practice. So I just want to hang my hat and just quit because it's like so good, and to watch somebody like Andrew Maynard's been doing this for a long time, he's just like, blah, how do they do that? His mind's blown. It's like if Andrew can't get this in his projects, like how am I going to possibly like get this going? But a lot of it had to do with the fidelity of detail from the vision of the entire project, no matter how big it was, and how every level of the interaction of that building goes down to how every like component connects to each other, how these like master grids are formulated through the building so that the fidelity is like we walked into this one museum that turned out to be one of my top two buildings. This museum, I didn't know what I was going into, so I came as a blank slate. And we're seeing like how the concrete, you have the concrete some forms, and so there's little lines in the concrete through buildings. That matched up with the tile, that matched up with the window framing, that matched up with how the hallways articulated, that matched up with the display rooms, that matched up with the stairs that went up to the top of the building, that matched with the bookstore in the wraparound glass of the bookstore, that matched up with the decking that you sit on, that's a big podium. All of that was completely aligned with each other. And you go like, this is furniture at this massive scale.
Yeah.
It was just phenomenal. So like, I'll never look at a detail the same again, and I'll forever be like trying to like hone in on how to develop that and articulate that level of connectivity through the entire design and construction process.
Talk about an elegance to that. I mean, even what you're saying, I was unaware of that, but it goes into the Frank Lloyd Wright in my head again because he would design the furniture in the homes as well as the structure and the layout of it and all of that, and all of
Yeah.
the way that you're describing it is some of his more infamous homes. I know from my family who are they're contractors. They build structures up in Minnesota, and I know from them that his homes tend to be quite leaky and terrible to live in. But as far as the design aesthetic, it's exactly that, which is
Well, these
fascinating.
were the 30s. I mean, insulation was optional.
Yeah.
We did go to two Frank Lloyd Wrights. We went to a school. Where's that school? The school's in Tokyo. It was a former girls' school. It was now a museum. And then we went to a house in Kobe or near Kobe. It those on a hillside. And boy, did he really, really, at least for the house, did he really absorb traditional Japanese, not just the construction, but the the volumetrics of the space making, and really like personified it. So every time I hear somebody say, "I want Frank Lloyd Wright," I always ask, "Which Frank Lloyd Wright?"
Yeah.
There's so many versions of him out there, and it goes back to like my book was called Hyperlocalization of Architecture. He was one of the original hyperlocalists.
Yes.
Like he really absorbed the local culture, materials, sensibility, but also brought his own craft, imagination, and personality into it.
Yeah.
So
Yeah, I mean, like his early work. I'm a big fan of his early period. Even like the book he published that kind of made him famous. Ironically, was actually published in Germany. Of his early period, I think it ended, it was 1930 or something like that, 1912 to 1930, something along those lines. Um, it was called Prairie Style, and the reason it was called Prairie Style is because these homes were built in the Midwest prairie, and it was meant to
yeah,
mimic it and be influenced by it. And it was much more of that type of um, aesthetic and rooting it to the area, which I did want to ask you questions about hyperlocalization and how passive homes, which we're getting close on time, so we'll have to do that some other time if you'd come back on. But it's
yeah.
interesting. Uh,
You guys want to do an contemporary architecture
Oh yeah,
podcast? That would be a lot of fun.
yeah, I would love that. Yeah, talk more about. I had some questions about hyperlocalization that we're able to get to, so that would be great.
Yeah, so I think Frank Lloyd Wright was a victim of the same thing Passive House is. Like we all think of Passive House as German boxy houses. We all think of him as the prairie home, but it's so much more than that, right? And the further you learn about it, the more you respect the level of thought and care that the people who are developing and practicing this goes into this, and how fundamentally like connected and the connective tissue that goes into creating essentially really complex, hyperlocal buildings because they're each one's built specifically for where, at least in performance side, for where it's placed on the planet.
Yeah, most certainly. Yeah, and it's amazing how just to stay on Frank Lloyd Wright for example, like his homes in Oak Park, Illinois, look totally different than his house that he did in Los Angeles. Right, like
Yeah,
they're totally different, and a lot of that's the materials. But he also would think about the lighting, and he was much, I would say, probably much more aesthetic driven than functional driven. Which what taking that to today though, it's interesting to think about it from the climate of the area. How's the climate shifting in the area? What materials do you have in that place to work with? Um, yeah, it's a fascinating thing to think about because it's a phase shift of how you would think about building, right? It's less about I want to be able to get this square footage until I can flip it, or that I can be able to have what I want in this dwelling as far as just the rooms and whatnot, versus well, what's it going to be like to live here for in perpetuity, or actually inhabit it versus living in it, I suppose.
yeah, and that goes to the whole kind of process of architecture and space making and the volumetrics and the materials and the feeling of a space. So there's the psychological feeling, there's the physical feeling, there's its conductivity to its local street and the further community above that. All those are a consideration in a good building design process. And so when you hire somebody and say, I want that, I want you to do what you did before, is the wrong question. You should be asking, this is who I am, this is where I live. How do we make a building that can make the best of those conditions? And so often for my intake forms, I ask them not to describe, for when I'm just meeting a client, do not describe what you like in terms of style for the house. I frankly don't give a shit what you want right now for the style house. Tell me how you live, what you do. The building is really just a measurement of human activity. So how do we articulate a space that transforms and improves that activity of what humans are going to do in that space. Yeah, with the least amount of environmental degradation and for the survivability, so for what's to come. So
I love that. That is so great. And can we have all buildings that have that type of forethought instead of this type of communist box gray that we have that's pervasive everywhere? That
well,
would
it
be
turns
great.
out that the communist buildings are the best buildings in Eastern Europe.
Ah,
The
yeah, yeah. Well,
apartment buildings
yeah, the
are
brutalists.
really popular
Yeah,
for good reason because they didn't over articulate. They are very simple and they had good community connectivity. So it turns out that communist housing is really quite sought after,
yeah,
ironically.
yeah. It's ironic though because the homes here that I'm making fun of and poking at,
Yeah, yeah,
um, here that the multi like I'm thinking of this one particular one. It's an apartment building that they built that it's a square building. It's gray. It's got black outlines above the windows and the balconies, but it's just a stick house. It's just a plywood with some stucco on it. It's not any of
yeah,
the brutalist concrete. So you
yeah.
lose those benefits.
I can only speak to my own design process and what I like. It's hard to generalize what good design is. And Santa Fe is funny because its buildings are completely different than anywhere else in the country, and I love them. They're adobe boxes essentially, but there's a cadence to them. There's a kind of a interesting survivability to them. But their roofs are terrible for this climate. For instance, they're just always leaking. So so there's always lessons to be learned. Um, but in Japan, I'm just absolutely fascinated on how the densification and the quality of neighborhoods and the connective tissues. So even an ugly building is really sought after because it's connected to a place.
Yeah, that's I love that. Well, thank you very much for taking the time and chatting. I definitely would love to talk to you again. Is there anything else that you want to connect or give a shout out to or anything like that while we're still here? We'll also have the show notes that folks should check out.
Yeah, I mean, you can check out the Passive House Network's website, which has a lot of just for the deeper dive. There's a lot of Passive House information out there. A lot of it's really good. Some of it's pretty terrible. So, where to start? I'd say go to the Passive House Network website and scroll through their kind of what is Passive House content for starters.
That's great. Yeah, and check the show notes. I'm sure I'll get some stuff from you that are the good versus the bad. And yeah, thank you very much for your time. I'm gonna pause the
Yeah,
recording.
you bet.